Hello there, ladies and gentlemen. Welcome back to the Ephemeris podcast, your weekly astronomy podcast. I'm your host, Aphelion, and I apologize for not having released an episode last week. I happened to be very busy that weekend, but we are back here with another episode on the ongoings of the world of astronomy currently. So, we're going to have a focus for this week instead of three articles. I mean, it is still technically three articles that we will be discussing, but they're all going to be centered around a single focus, and that's going to be space missions and projects. So that's the idea, the general idea for what we're talking about today. I will say the first two stories are not the most optimistic. In fact, I would say they're a bit depressing. But at the end, we do have a slightly more optimistic story. So if you're not in the mood for less optimistic content, then I would not blame you for clicking away from the video or choosing to skip to the third story, which is a little bit more on the lighter side of things. But the three stories that we will be talking about today are recent budget cut proposals for Chandra, I should say, the new direction for constructing American ground-based telescopes, and then the proposed UVEX mission by NASA. So, first story, this is pretty much going to be me talking about what I think is an elephant in the room because it's an issue that has been addressed by, I guess, the biggest science channel on YouTube, Veritasium. And so for some of you, this will not be news, but for some of you, it will. But either way, I thought that, the fact that it's been addressed by more popular people should not stop me from further discussing the issue. So, yeah, that's what I'm going to do here. I'm going to discuss it a little further and talk about what this really means. So, the Chandra X-Ray Observatory. It's a space telescope operated by NASA that was launched in 1999. And a quote from one of the articles I was reading as I was researching this issue stated that Chandra is an X-ray observatory which allows astrophysicists to map both hot gas that is critical to understanding the formation of stars and galaxies that make up our universe, as well as high-energy particles that belong to extreme systems, such as supermassive black holes, supernova explosions, and more. So, yeah, I thought that was a really, really nice summary for what Chandra does, and it's named after Subramanian Chandrasekhar, which we have an episode on, so feel free to hop over to that episode if you want to learn more about the man behind the name. Chandra is among the fleet of great observatories which were all launched in the 1990s, and this group of observatories includes Hubble, Spitzer, and the Compton Gamma Ray observatories. If you've tuned in to previous episodes, you'll see that the Compton Gamma Ray Observatory, its name has a link to the Compton camera, and each of these telescopes that we've just discussed here is designed to specialize in a specific portion of the electromagnetic spectrum. So Spitzer specializes in infrared, Compton specializes in gamma rays, Chandra specializes in X-ray, and Hubble takes care of the near-infrared, visible, and UV portions of the spectrum. So together, these telescopes, you could say, form somewhat of a dream team in terms of observing the universe and the data that they collect. Obviously, some of these telescopes have been decommissioned, like Compton did in, I think, what was it? Was it 2000 or 2020? I think it was like completely gone by 2020, but its primary mission ended in 2000. If perhaps I have that incorrect, but that's what I think it is. Hubble is gonna be succeeded by James Webb Space Telescope and things like that. So these telescopes are bound to be replaced at some point, but some of them have been going still for more than 20 years, and the two that have really that I'm mentioning here are Hubble and Chandra, and they're still going strong. So first, let's talk about what Chandra has done in the 25 years that it's been out there. It's observed many regions with high energy and hot temperatures in amazing detail, and one example of this is given on the Chandra website, where it looks at the Crab Nebula and some of its emissions. Like it looks at an observation from non-X-ray telescopes and Chandra side by side, and you can see a very, very clear difference in the detail that you get from Chandra's observations. It's a very high quality telescope that has a good I think what was it? It was angular focal length or something like that. I forget what it was, but basically it's able to capture images in very, very great detail. And with that ability, it targets high magnetic fields, gravity, or high magnetic fields, high gravity, and high explosiveness regions in the universe, and it does an amazing job at seeing through galaxies and their hot gas and black holes. Lots of different things. Like Chandra was very, very important for understanding Sagittarius A star, which I think we've talked about before this season. So yeah, another quote that I collected that I think puts this all together very well is, Chandra has offered many insights, including how supermassive black holes can coexist in the same galaxy, that Einstein's theory of general relativity holds, so space-time is a continuum, and the first direct proof that most of the matter in the universe is dark. So, yeah, Chandra has done some very, very important work in that regard. It also confirmed the first gravitational waves that were captured by LIGO, and it led to a Nobel Prize being given to those who were a part of that research, and it confirmed Einstein's theory once and for all. So that is the great history of Chandra, and despite its minor issues in terms of maintaining it, it is still very much it's very useful to this day. But the issue with Chandra is the amount of maintenance that it requires, and that requires funding, obviously, from, it requires funding that's given to NASA by government departments, and we're talking like millions, probably billions. Yeah, for NASA, it's billions of dollars of funding, but specifically for Chandra, we're talking millions of dollars of funding. And in fact, it's millions of dollars that Chandra might not have come next year, because the American government has proposed to slice NASA's funding for the 2025 fiscal year by $1 billion. And that will force NASA to limit Chandra to $65 million in the next 2 years. And it sounds like quite a lot of money, but for only a single year, it takes $70 million to keep Chandra going with active maintenance, in the words of NASA personnel. So, yeah, basically this budget is threatening to end the life of Chandra. And it's really, really sad news on many levels. I'm not going to get too deep into, like, the politics of it, because, ultimately funding decisions are politics, and they're, certain decisions that people have issues with. This one's going to be one of them, and there are a multitude of other ones in comparison to this funding that people have issues with, and I'm not going to get too deep into that. But what is clear is that this decision has not been received well by the astronomy community. Chandra has not completely run its course yet in terms of its usefulness to many astronomers who are using it for research and stuff. And the budget cut is essentially going to end the Chandra mission because like it's a 40% budget cut for this year, and it's going to be even less for the next year. So yeah, the next X-ray telescope won't be ready to launch until 2032, so we can't look forward to an immediate replacement for Chandra. It's going to take another 7 years to return to high-quality X-ray observations if this budget cut actually goes through. And that means a limiting of opportunities for people in astronomy. As I talked about, they're like researchers, PhD people, or like, doctorate and postdoctorate researchers who are relying on Chandra for X-ray observations. And if that's cut off, not only are the present researchers going to be pushed away from the field, but it also means that future astronomers will be pushed away from X-ray astronomy. And once there is a new X-ray telescope, nobody's going to be there in that field. So yeah, that's pretty much the assumption. I won't say that it's clear cut in stone, because ultimately this is a budget cut proposal, and there are organizations that are looking to reverse this decision to cut the budget. And the sort of scenario here that I've laid out is sort of proposed by people who are in the field, but that's pretty much what that's the best outlook we're going to get for what this budget cut means, and I wanted to mention that. And before I wrap this story up, it's also important to notice that Chandra is not an X-ray telescope that functions on its own. It does a lot of work in coordination with ground-based telescopes, and this collaboration between different observatories to create just like the necessary data is something that's very important. And if you lose one link, the whole chain kind of weakens, I guess. And that's going to be obvious through things like, composite imaging, that, you need different parts of the electromagnetic spectrum to do. So yeah, lots of different issues that arise with this news. So yeah, again, I had prefaced this episode by saying these first two articles are going to be definitely downbeat, but that's just the fact of the matter at the moment. The second story that we're talking about here takes us from space telescopes to ground-based telescopes. And if we are to put ground-based astronomy into context here, it's in pretty good condition. The ESA and European space agencies, other than that, they've got like the European Southern Observatory, and then for the United States, we've got like the Rubin Observatory. There are other telescopes around the world, like the Very Large Array, Very Large Telescope, James Clerk Maxwell telescopes, and that's all great news. But our goal in the future for ground-based astronomy is to expand the number that we have, so that once again all of these telescopes can collaborate to create more detail in the map of the universe that we have right now. So there are currently 3 future ground-based telescopes in the works to expand our scope on the ground. So we've got the Extremely Large Telescope, which is probably a run-on of the Very Large Telescope. There's the Giant Magellan Telescope and the 30-meter telescope. The Extremely Large Telescope has progressed quite well so far because it is managed by the EU, and they plan to start operation in 2025. The Giant Magellan Telescope, it began its construction in 2012. Some of its mirrors have been finalized, others are not. It's on a pretty good track. The 30-meter telescope, though, it's run into some problems in terms of actually making the telescope in Mauna Kea and sort of the claims over the land by natives and their desire to manage that land as they please because there's already many observatories there. So, yeah, with that being said, the 30-meter telescope is probably the most behind in its construction, but it's still in progress to some degree. So, that's the state of the three future telescopes, the three major future ground-based telescopes, and that lands us at our story today. So, the National Science Foundation, which is overseeing the construction of the 30-meter telescope and the Giant Magellan Telescope, has limited the funding, or has their funding has been limited to $1.6 billion. And because these two telescopes are going to cost a lump sum of about, I think, was it $2.4 billion or something like that? That means that the funding that the National Science Foundation is allocating to these projects isn't enough for even just one of them on their own. So what we should take away from this fact here is that the National Science Foundation has essentially killed the prospects for one of these telescopes. And it won't necessarily be that the 30-meter telescope will just be abandoned in totality, because there is still some progress that has been made on that project. And the 30-meter telescope would complement the extremely large telescope in the southern hemisphere rather than the Giant Magellan Telescope. Because what's happening here is that these three telescopes are being placed or the 30-meter telescope and Giant Magellan Telescope were intended to be put on opposite hemispheres to be able to scan the whole night sky. And so if you take away a 30-meter telescope, then you're going to have the extremely large telescope that's in the north, and you're going to have the Giant Magellan Telescope that's also in the north. So it's not necessarily the case that the 30-meter telescope will go. But we are losing the potential for a dynamic duo, I guess you could call it, that would scan the entire night sky together. And both are in progress. It makes the situation really, really weird. The only thing we can wish for is that the government will choose to chip in a little bit more money to make it possible. But based on the last story, that is definitely not happening. So with the two depressing stories out of the way, we should talk about something a little bit more optimistic, and that's going to come in the form of the Ultraviolet Explorer that will now launch in 2030. It was initially intended to launch in 2028, but I think we should be pretty familiar as to why there were some issues with getting it up by 2028. So UVEX is basically the abbreviation for it, or I should say UVEX. I don't know, I think UVEX is nicer. So it's going to explore the universe's ultraviolet emissions for a multitude of purposes. Firstly, it's going to collect new data on stellar evolution, which I'm assuming is going to be for larger and bluer stars that are actually going to have emissions in the ultraviolet range. The UVEX telescope will also collect spectrographs for stellar explosions, and one example of such an event would be a neutron star merger, which tends to be heavy in UV emissions. In collaboration with the Euclid and Roman space telescopes, which are both intended to collect data on the gravitational effects of dark matter and energy, UVEX will help build the map of the universe in the ultraviolet range of the electromagnetic spectrum. So that's the case for the purpose of UVEX, and its primary mission lifetime will be 2 years. And the general rule of thumb is that any space telescope that has a primary mission lifetime of 2 years or more is a very successful telescope. And this might sound odd because we just talked about like Chandra and Hubble being out there for like 25 years or so. Um, what should be understood here, though, is that primary mission lifetime likely represents a specific time period in a telescope's usefulness where the telescope will do most of its important data collecting. So after that, um, it's probably up to those who request data what the purpose of UVEX will be or any other space telescope, and that's where um, most of the telescope's lifetime will be in. But yeah, that's basically the case between the difference of primary mission lifetime versus how long the telescope is actually useful. Lastly, I will leave off a little data point here, or sorry, a fact, just to gauge the numbers. UVEX is expected to cost $300 million. So, yeah, that's all I got for UVEX. Before I leave it there, I think it'd just be nice to wrap up with some other new projects that are coming up for NASA. So, we just talked about the Roman Space Telescope, which is going to launch in May of 2027, and it's intended to observe objects ranging from stars, planets, and icy bodies to isolated black holes. And Roman will conduct a survey known as the Galactic Bulge Time Domain Survey, which will use the telescope's infrared vision to stare through clouds of dust and gas that usually block our view of the central bulge of the Milky Way, where a vast amount of stars are concentrated. It's also important to note that the infrared vision of Roman will be helpful for studying exoplanets or like rogue planets and stuff like that. There's also the Habitable Worlds Observatory, which is being prioritized by NASA as a future project. I think the name is pretty self-explanatory. And yeah, that's all I've got for today and this episode about space missions and projects. If you enjoyed this podcast episode, which, I mean, it's kind of hard to enjoy when you're hearing about such sad news, but if you were interested by the content, let's put it that way, I would sincerely appreciate a subscribe on YouTube if you're listening on YouTube, and a follow on Spotify if you are listening there. For my returning viewers, once again, sort of it's become a habit now that I remind you all to make sure that your notifications are turned on to all so that you receive notifications for whenever I upload. And yeah, until the next episode, I will see you all later. Peace.